Hi, Spring fans. Welcome to another installment of Spring Tips. In this special mid-season interregnum episode, we're going to revisit the topic of building native images out of Spring Boot-based applications using Graal. Now, I just did a video maybe 2 months ago, so this is not a subject that has wanted for coverage. I just feel like the new release, the very most recent release that was well documented here by a great blog post by Sebastien Deleuze called The Path Towards Spring Boot Native Applications, was so compelling that I would love to actually just do a video based on the stuff in here. So there's a lot of stuff. Um, Suffice it to say, we have a project called Spring GraalVM Native 0.7.0. Actually, it's 0.7.1 right now. That was just released like a week or two ago, and it represents a huge step forward, even compared to where we were back in April when I did the last video, which was itself a huge step forward compared to where we were, in 2019. So I am super excited by what we've got here. The main thing that you can see here is that now a whole class of applications just works out of the box in a repeatable way, assuming you use the same steps, right? Which is super nice. There's no manual work. I mean, there's still going to be some of that, of course. There's still going to be some kinds of applications that just don't work out of the box. That said, that list is growing smaller and smaller, and this release already is a huge leap forward in that respect. And the next release, 0.8, will be an even bigger step. So we're going to return to these topics in a minute, but just a quick review. GraalVM is a just-in-time compiler C1 replacement for OpenJDK for Java that also has a separate component that's an ahead-of-time compiler, and that thing can be used to take a Java JVM-based application and turn it into a native image. These native images start up in no time at all. They have much less RAM requirements. They take up tens, not hundreds of megabytes of RAM. They can start up in a tenth of a second. And while the latency or the cost of any individual transaction, any individual request might be more than, for example, in a JVM-based application, it's not much more. And you could run two instances of the same application and put it behind a load balancer and take up less space in the container and in your server, your host server, than if you were just running one super fast one. So either way, it pans out pretty nicely. So there's a lot to recommend this. It's also a native image. So these native images, yeah, we've lost the right once run anywhere benefit, but most of us are deploying to Linux. So if you compile your code on a CI environment running Linux and then deploy it there, you'll be fine, right? But because it's a native image and it's sort of a statically linked binary, sort of like a C application with everything linked statically, you don't need to have a JVM. So you can take the admittedly pretty heavy, several hundred megabyte sized native image, drop it into a container with absolutely nothing. You can use from scratch in your Docker files and just run it, right? So your configuration goes down to nothing. Your runtime environment goes down to nothing. Everything is just simpler and more efficient in this way. So the only drawback, of course, is that it takes a long time to compile. But that said, it's getting better. So what we're going to do is we're going to build a couple of applications today. Going to start that Spring.io. We're going to use Spring Boot 2.3.1, and we're just going to build a JPA application. We'll use H2. We're going to use Lumbuck, and we're going to use the regular Spring MVC with Apache Tomcat defaults. Okay. Now I've got Graal on my local machine here. I've just done Graal, and I've got I'm using SDK Manager, so SDK list Java, and you can see I've set my default as GraalVM 20.1.0 using Java 8. I haven't tried with Java 11, but I see no reason why that wouldn't work. But I'm just using Java 8 since that's the entrenched majority at the moment. So we're going to use that. Obviously, if you can, you should use at least Java 11. So I've got now an application. I've just generated it. I'm using an embedded H2 JDBC database. I'm using Lumbuck, and I've got a web endpoint. So pretty standard stuff. And I'm using JPA, right? I'm actually using Hibernate here as well. So that does a lot of stuff that we need to know about as well. So remember, when you generate native images, your application has to be, it may have dynamic behavior, but Graal wants none of that, or at the very least, it wants to know about all of that ahead of time. So you need to tell about any kind of funny business. Anytime you dynamically generate a class or do reflection or load a resource from a URL in the jar or anything like that, it needs to know about it. And so there's a lot of configuration that's required. In my last video, I showed how to manually run the agent to the Spring Graal feature, which is like a Java agent, but it gets run at the build time. At the runtime for your JVM application. I showed you how to run that feature and then capture configuration. But now a lot of that just works out of the box. So, I'm not going to show you that again because we don't need it for these applications, right? So what I'm going to do is I'm going to take my Spring Boot application. I'm going to build an application that, let's see here. It talks to a database using a Hibernate, right? So I'm going to use @entity. Or not. Let's see, do I have JPA? Oh, I forgot JPA. We can fix this. We can fix this. JPA. Okay, there we go. Control B, copy, Control A. There we go. So now I've got Spring Boot starter data JPA. Good stuff. Now, go here, @entity, and @ID, @generated value, private integer ID, and private string name. Now these are Java classes, obviously, but I want getters and setters for Hibernate, so do that. It was Lombok again. Okay. Now I need a repository. So a repository extends JPA repository. Yep, there you go. Managing entities of type customer whose primary key is of type integer, and we're going to write data to the database. So I'll just create a application listener that listens for the application ready event, and that's Spring Bean, and a customer repository. I'll just inject that through the constructor, which I'll synthesize using a Lombok. Okay, so required args constructor. There you go. Now, what I want to do is I want to save a single record, maybe 2 records, it doesn't matter. So I can say stream.of Madura and Dr. Sire, and for each one of those, I'm going to take each name, turn it into a new customer, okay, like so, and then just save it. So C, this.customer repository dot save C, and then we'll visit, right, for each print line. Good. Okay, there's the saved application, and then finally I'm going to have an endpoint, an HTTP endpoint, so a customer REST controller. Okay, not a big deal, just typical endpoint. Get mapping customers, collection of customers, private final customer repository, and acquired args constructor, this. Okay, there's my endpoint, right? So that's what the application looks like. Let's go ahead and run it. Let's just make sure everything's working normally as a regular JVM-based application. Should be fine. And then once we've done that, we'll turn to making this a native image application. Now, I've got GraalVM running on the background, like I said. I had to do gu install, I think, native image, I think, something like that. Make sure you Google that, but there's a command you have to do to install the native image support. There's my application. Localhost customers. Seems okay. So there we go. We've got data. Now I want to do the same thing, but using GraalVM. So there's a few things you need to do to make this work. First of all, again, we're going to disable certain dynamic behaviors in Spring, right? So certain things are going to go away, including this. We're going to disable the Spring Data Web auto configuration, and we're going to proxy. We're not going to proxy bean method. So if you ever do @bean, foo, whatever, like this, that when we see this, we actually create a subclass using cglib normally, and we dynamically extend that, and we do some memoization. So if you use the dependency injection mechanism, where you actually just have a bean reference to another bean, and you create a parameter in one of your bean provider methods for a bean of another type, that'll just work no problem. And you can even do method invocations. You can actually have one bean provider method invoke the other one. Just know that if you do it more than once, you're going to actually end up, you're going to end up recreating the same bean more than once. So it's better to not do that, right? But you wouldn't end up recreating it if you were using CGLib. But since we can't dynamically do anything besides JDK proxies, we've had to disable that. Okay, so not a big deal, easily avoidable problem if you have it. And there's our application. So now let's turn this into a native image. There's a few things we need to do. First and foremost, we need to change the build a little bit. Okay, the build is going to be important. So first things first, we need to add a plugin, a Maven plugin for Hibernate. So Hibernate does a lot of dynamic stuff as well, right? So we need to get it to enhance the JPA entities at build time as opposed to at runtime, which is what it normally does. So here's a build plugin. I'm going to paste that in. And the build plugin, I'm using org Hibernate ORM tooling. I'm using the version of Hibernate that's managed by Spring Boot's auto configuration and dependency management. And I'm telling it to just do certain things, but basically enhance the classes so that there's nothing required at runtime. That by the time we go into the compile phase, all of it is done for us. And then finally, since we've done that at build time, we need to tell Hibernate to not do it itself, to not not worry about it. So we're going to do a Hibernate Properties file. And here, we're going to use a simple property called Hibernate Bytecode Provider. So there you go, Hibernate Bytecode Provider equals none, okay? So that's the extent of what we need to do for this. We also need a few dependencies, and you're going to see that I'm going to put these everything I just showed you, that's all for, for this JPA Hibernate example. Everything I'm about to show you is going to be common to every application that I could write here. So I've just copied and pasted these three dependencies: Spring GraalVM native, Spring GraalVM native 071, the Spring Boot configuration processor, and the Spring context indexer. The indexer, I'm not sure if you need that for each one, but it's nice. Since we're using an experimental, not yet GA Spring Graal native support, I've also had to bring in the right repositories here. So that's pretty typical. In fact, if you go to start.spring.io and generate a new project using a snapshot, you'll automatically get that, right? So I'm using 2.31, but there's nothing here special beyond what you would have gotten by going to the initializer. So with that, let's compile our application, make sure that works, and then we'll compile it with Graal, okay? And that's where things get a little interesting, but not that interesting. So actually, I'm going to go here, CD downloads, JPA, Maven clean package. Alrighty, Java -jar target JPA, make sure everything's happy. Looks good. So there's our data reflected in the output there. So I've done something that's read data. I wrote data to the database and I read it out of the database. I have an HTTP endpoint, localhost, customers. So you can see that my regular JVM based application is working just fine. Now I'm going to compile it using this compile script, and I've included this in Git repository, which is under github.com spring-tips. That's the organization, and then you can find Spring and Graal, part 2 or something like that. I haven't really named it, but I've got the script that I've written here that does all the work, right? And I'm going to reuse this. I could reuse this for lots of different applications. It requires the artifact name, which in this case is going to be JPA, the name of the main class, public static void main class, and then the version, which in our case would be 001 snapshot, right? I'm deleting the target directory, making a target directory and a native image directory, doing the build, again, no reason, but I am. Deleting the artifact itself, which is the, I'm making sure that this is gone if it exists, the native image. And then I am going into the target directory, to the native image directory. I'm unpacking the jar. I'm copying the meta-inf classes into a directory called boot-inf classes. I'm then generating a class path. I'm generating a list of all the libraries in the lib directory and creating a string that I can then pass into the build process, and putting everything in the right directory. And then I'm actually running the build. So I'm using native image. Time just measures how long it takes, but native image is the actual thing that does all the work. And you can see here, we've got a bunch of features that we're feeding into the build process to disable certain parts of Spring. We're disabling JMX, right? Because that doesn't work well, and we're not about to, I want to get this to production. JMX is probably not going to be the thing I use to monitor my application, so don't need it anyway. Goodbye. I'm going to disable Spring expression language. So that's actually you know, depending on the age of your application, you might have a lot of Spring expression language stuff. Sorry, no way around it right now, but you know, hopefully it'll come back. And then of course YAML, right? We're getting rid of YAML. You could also get rid of the XML support. I don't have it. I don't need it, so I left it in. It's fine. But these are options. These are flags that you can use. And then of course I want the verbose output to make sure I can see everything that's happening. And then finally, I hand it the class path, which is the environment variable there, CP. That's this bit right here. And then pass in the main class and compile it. And that takes several minutes. So we're going to go ahead and start this process up using the compile script. And you know, let's recall the first thing we need is the artifact, then the main class, and then the version. Okay, so artifact, main class, and version. So the artifact is JPA. The main class is com example. Okay, copy. And 0.01 snapshot. Okay, let me just make sure of that. Looks like it, right? There it is. So, paste. Okay, that's going to take several minutes. We're going to come back to it in just a bit. I've already compiled it. You also need to make sure you do a Maven clean install, but that's fine. Now, the next thing I'm going to do is I'm going to go ahead and build a reactive application, right? Same basic idea. I'll do reactive, and we're going to do reactive web h2 r2dbc, and that's it. I guess that's it. Oh, and Lombok, of course. Lombok. Okay. Hit generate. And we'll go back to our build. Downloads. UAO reactive.zip. Okay, and in the reactive one, we're going to do basically the same thing. We're going to actually create a repository. So actually, I wonder how much of this I can copy and paste and still get the job done. Not a lot, mind you, but some. Well, actually, possibly a lot. Look at that. So I need to do a reactive stream instead. So I'll do flex.just. And then I'm going to say flat map. This is going to in turn extend the reactive CRUD repository. That's not a JPA entity. The ID type is going to be from Spring Data, not from Hibernate. And of course, there's no for each, so I do a subscribe instead. All right, and this has to be a publisher, not a collection, but otherwise it's basically the same thing. All right, so that actually got us a lot of the way there, didn't it? So we can use that. We can use these two bits here. Okay, and the only other thing that's different is that I need to actually initialize my schema since I'm using H2, and I don't have the auto schema initialization thing here as I do with Hibernate, which will look for a schema which will create the schema for me based on the entity. So I'm going to create an initializer. Actually, I've already got an initializer. I'll do that here. So this is a reactive stream. Okay, save, and then I'm going to inject the reactive R2DBC client, database client, and going to create some SQL. So SQL create table customer ID serial primary key name var car 255. Okay, and so I'll say this database client execute SQL fetch rows updated, then many save, and then many find all the data. Right, so and then finally subscribe. Good stuff. Good stuff. So that's the new application. Let's run this one as well. Same thing as before. Okay. Run. And meanwhile, has this other one finished? It's almost done. Still cooking. Lots of stuff happening there. Hibernate and Tomcat take considerably longer than the reactive stuff. But even this is all like the Hibernate and JPA one when I did this video the last time, just a few minutes ago, took 10 minutes. Now, maybe 4 or 5 minutes. It's amazing the leaps and bounds we've gotten to. By the way, that says a lot, right? This is not the kind of stuff you're going to run when you do your day-to-day dev cycle kind of work, right? You're going to do this after applications have gone through your development cycle, and then perhaps in the CI environment right before you push to production or your integration testing. Okay, so that seems happy. Let's go ahead and now turn it into a native image. Same basic approach, right? So cd reactive, and here I'll just use the same compile.sh, and it's going to be reactive, and the main class is this. Oh, I forgot to do the dependencies, right? So I have to go back here and copy and paste all that stuff that we had from last time. Okay, paste, and then take that and put that over here. So there's Spring GraalVM native, the Spring Boot configuration processor, and the Spring context indexer, and I've got my Maven repositories, but otherwise everything is basically the same. Okay, nothing too phenomenal there. So what I'm going to do is we're going to compile that. Oh, you can see the JPA applications well underway. So we'll do Maven clean package for the compile one, for the reactive one, and then compile reactive. Okay, look how much memory the compiler takes for Graal, the native image process. It's just insane how much memory it takes, right? It's gigs and gigs of RAM, and you know my fan says hello. My computer fans they're barking right now. They're not happy with me, not one bit, and that's because we're making them do way too much work. But the result you pay for it upfront, and the result hopefully is what you want, right? So I'm sticking around here waiting for this one to finish. It's hopefully going to finish sometime soon. Look at that parse. That's important. I know what parse is, don't you? We all know what parse is. I don't know what parse is. I don't even know why they're telling me this. I just want to see the result. But we're almost there. The benefits here of using GraalVM in your applications is for resource efficiency. So it seems like I've spent a lot of time in the last few years just talking to people about efficiencies, right? Gains in performance and robustness and efficiencies, because it's fair to say that Spring is pretty darned flexible and pretty darn powerful and productive. And productivity is always the first and foremost concern here. But what we want now is to eke out every last drop of performance and efficiency. So I've been very happy to be talking about reactive programming for the last couple of years, 3 years actually, no, more than a couple of years. I've been happy about that, and I'm really happy to see us embrace GraalVM and native images in this way. The result is already super compelling, but what's coming up in the Spring Graal 0.8 release is even more promising. There's already a research project that we've been doing where we evaluate the impact of using functional configuration with configuration-based classes. So if you know about Spring's JaFu project, the Java Functional Configuration Project, or the Spring Kofu Kotlin functional configuration, then you know about this approach to doing functional configuration. You can do it in regular Spring Framework, right? It's actually a feature in Spring Framework 5 where you can define beans functionally by registering them dynamically, as opposed to having methods annotated with @bean and so on. This approach is faster. Forget about Graal. It's just faster in a vacuum. You don't need Graal to see that benefit. It's also much less memory, right? An application that might take 70 megs of RAM, it might be half as much memory in some cases, right? As a native image, it's still about half as much memory. Well, we're evaluating being able to take @configuration classes with @bean methods, and then dynamically at build time turn them into functional configuration. So you get that performance benefit without having to rewrite every bit of code you've ever written that uses @bean. Okay, so our JPA one worked. Let's check it out. Target, native image, JPA. Oh, that's nice. Okay, that took a long time, 0.4 seconds. Let's kill that. Target again. There we go. 0.7 seconds. Oh, you know what it is? I'm compiling. my computer is very unhappy. 0.3 seconds. So let's wait for this one to finish, and you can see it's nearly there as well. How long did that first one take, I wonder? That first one, real time, 7 minutes. Okay, so that took a considerably longer than I was expecting it to take, but nonetheless, we're, we have a native image. And point, no, I Control-C the wrong one. I have to restart the time it takes to compile this application here. Not bad. It's still better than the 10 minutes I showed a few months ago. Now, going back to what I was talking about, we have support. We're working on support to automatically rewrite that configuration at build time so that it ends up as functional configuration behind the scenes. We've also done a ton of work in the Spring Graal project to support targeting or targeted substitutions of certain code paths that would run afoul of Graal's very, very strict doctrinarian sort of prohibitions on dynamic behavior, right? So those targeted substitutions are things that Graal will substitute for you instead of executing it directly. So it's a class. So if a class does something dynamic, we can actually swap that class out using a substitution. And we have a whole little framework that does that. But of course, that's not sustainable. It's a non-goal to have to continuously maintain a list of substitutions on the side adjacent to the actual code bases. It's something that we have to do for now because even as we work steadily and speedily to change Spring wherever necessary to support these new requirements to support GraalVM, we can't force everybody to go that quickly. So these substitutions allow us to address other projects that integrate with Spring and substitute those things, right? So we have that for now, but the goal is to remove as much of that as possible. And a lot of that has been already addressed in the just released Spring Framework 5.3, the GA Spring Framework 5.3. So we've been working on this for years now, a couple of years. It's just nice to see that 5.3 has those things. So this new release will take advantage of Spring Framework 5.3. It'll take advantage of the Spring Boot 2.3 as well. Obviously 2.3x, we're using 2.31. So lots of really interesting possibilities. And we've also got, Julien Dubois, the founder of JHipster, and my buddy. He's a developer advocate over at Microsoft, and we've done presentations on Azure Spring Cloud and Spring Cloud for Microsoft Azure. He had a great thread about using Azure Spring Cloud. About using Spring Cloud Function with Microsoft Azure Function. So you can actually write, FAS, FAS, Function as a Service centric applications using Spring Cloud and GraalVM and native images, right? We also have, that's a supported thing. Dr. Sire talked about that recently as well. We've managed to get this working obviously in container-based environments. That's ideal for Kubernetes. We've got it working in for Kotlin applications as well. So really, really good sort of possibilities here. I just saw this right here, Spring Data MongoDB. That's a great point. When you look at the code for this Git repository, for this demo, for this example that I'm doing right now, you'll see that I've already got a MongoDB example there. I'm not live coding it because it's fairly similar to the JPA one, minus the Hibernate enhancement plugin and minus the Hibernate type property. So everything else is the same, right? Reactive MongoDB or non-reactive MongoDB. It's much less than using Hibernate, right? Much less configuration. And here's the functional configuration that I was talking to you about earlier, right? Here's an example, an application context initializer. You get a reference to the application context, and you dynamically register beans, and then provide a supplier that returns an instance of the bean when it's required by the context. Wouldn't it be nice if you could take this and have the agent just rewrite it into this for you? If you write your code today using this, by the way, you can, right? You can already do that. If you write your code using that today, as opposed to this, the resulting application will be much smaller and be even faster when converted to Graal. It's already a win. It's a win when using the JVM, and it's a win when you're doing native images. Okay, so the reactive application is working. I'm glad I didn't foolishly Control-C the build as I did just a minute ago there. So target native image, reactive. Okay, so the first time Takes a few seconds. Why is that? Control C. There we go. That's more like it. So 0.14 seconds. Control C. Right, 0.152. So, you know, pretty quick. Oh, it's because I'm recording. That's the other thing to consider. I'm recording right now. Okay, so customers, there's my data. Okay, that one worked just fine. Good. Now let's see what this one looks like. So, target native image JPA. Okay, that one's at 0.258. So both, you know, crazy fast. This one, let's try this one again. Right, 0.275. So if I go back to this here, you know, it's the same endpoint, same data, of course. So if I Control C, go back here, you can see I've got nothing in the response, right? So super fast, 0.273. There you go. I hope you learned something from this, friends. I hope you read that blog. I hope you try it out. There's some really interesting opportunities here. You should definitely check out the code base for Spring Growl because we're doing some crazy things in there. And by the way, that stuff I was telling you about for configuration to functional configuration, that's not like a good idea. We've already got success. We've already had some success in some prototypes, and hopefully that'll be in 0.8, which is the next point release after this one, right? So stay tuned and obviously watch the space for more. Thanks so much for watching and enjoy.